You know, after growing up with movies, I always thought getting into electrical engineering, transformers were going to be a whole lot cooler than they really are. But honestly, transformers are actually pretty cool the way they work. Here's a transformer that can be disassembled to give you a better idea of how these devices actually work. And most houses that are supplied with energy from the grid have transformers nearby. The main purpose of it is to step voltage up or down, which means high voltage can be stepped down to the low voltage that's in your house, or in the case of some pieces of equipment, it can take the low voltage that comes out of an outlet and step it way up for certain applications. Transformers always consist of two coils that are wrapped around an iron core. These two coils are referred to as the primary and secondary coil. The primary coil is the one that is supplied with electricity. The secondary coil is the one that supplies the electricity off to the load or the end device. Now, in most cases, the primary coil is the one that's going to be operating at a higher voltage. This is what's called a step-down transformer. So it has a lot more coils on it. The smaller voltage side has fewer coils. Mathematically, those coils can help us determine exactly how much the voltage will step down, but the exact math behind that is more than we need to go into right now. We're just talking about the operating theory. When the electricity goes around this coil, it creates a magnetic field which polarizes the iron, the ferrite, inside of this iron core. As that polarizes, it also polarizes the rest of the iron around it. As it changes polarity due to the alternation of the voltage, it also alternates the polarity of the magnetic field inside. If we look over here at the secondary side, the iron is also changing polarity inside, creating an electrical field which drives an electrical current in the secondary side. That's why they're sometimes called isolation transformers. I can touch these two wires, and I'm not physically connected to the electrical outlet. But I am getting electricity that's supplied and the power is generated by the outlet. So they can be called isolation transformers, which often have a 1-to-1 ratio. There's no change in voltage, but there is electrical isolation. Step down means the smaller voltage, which actually happens to be at a higher current, hence the bigger wires for the lower voltage side. But in some cases, it can also step up the voltage for pieces of equipment. This one actually came out of a gas-charged laser and required a much higher voltage supplied by a lower voltage. So that's an example of a step-up transformer. Sometimes, transformer cores will be created with a material that's sliced into very thin sections and then glued or laminated back together. This keeps an electrical current from traveling inside the coil, inside the iron itself, which is referred to as eddy currents, and they can cause it to not only heat up, but also lose a little bit of the energy that should be going into the secondary coil. They call those laminated cores, and you'll also find them on motors for the same reason. So while transformers, in this case, may not be quite as cool as the ones that we've seen in the movies, there's no doubt these things are actually pretty cool devices, and learning how they work is pretty awesome.